So if that's the case, number one, less proton through F0, less ATP. And because there's less ATP, Zaire, it does mean that initially we're going to increase our metabolic rate, therefore increase Krebs, increase ETC to try and make ATP. So initially, what's going to happen to the CO2 production? That's right. There'll be increased CO2 production, which therefore will cause hyperventilation to excrete it, and possibly for the first 30 minutes or so get respiratory alkalosis. Is that okay, Zaire? That's number one. Let me insert a page right there. Duck. Number two. Since increased CO2 and increased water is going to increase proton plus bicarb, there is also metabolic acidosis. So first you had respiratory alkalosis. Second, metabolic acidosis causes normal pH, yet low PCO2 and high protons, and low bicarb. You okay with the compensated state? Adults, around 5 grams of aspirin. It's a stable state. But look what's going to happen. Number 3. If more than 5 to 10 grams aspirin, less in children, then decrease ATP ultimately decreases neuromuscular function. You need ATP to have respiratory centers fire. You need ATP to have skeletal muscle contraction, and therefore you're going to get respiratory depression. And respiratory depression is now going to cause respiratory acidosis with metabolic acidosis. You now get a mixed acidosis. Is it clear? The 3 stages? Is that okay? So initially it goes up when there's no compensation going on, as I am. But then, of course, your kidney rapidly gets rid of that bicarb. Is that okay, Zaya? So now you get your mixed acidosis. So your key point is, yeah, there is respiratory alkalosis initially, but it's short-lived. And you know, an example of this is run on a treadmill. When you run on a treadmill, you lower your ATP because you consume it, so you increase your metabolic rate. And as you increase your metabolic rate, Well, you start increasing your temperature, you start sweating because of that, and you are panting like crazy, you hyperventilating to blow out all the CO2 that you're producing through the increased metabolism. But after about 15-20 minutes on your treadmill, what happens to your breathing? It becomes much more in depth, slower, and now you literally manage your ventilation to match the metabolic production of CO2 and protons. And you are in phase 2, where you have basically a metabolic acidosis going on together with a respiratory alkalosis that match perfectly well, and your pH is stable. The problem with too much aspirin, unlike exercise, is that eventually the lack of ATP is going to suppress your respiratory centers and your respiratory muscle, in which case you're going to end up with a hypoventilation on the background of a high metabolic rate. And now you get the combined acidosis, and now you either going to die or you need the emergency room to do supportive management. And supportive management is going to include, of course, increasing the clearance of aspirin by raising urine pH, giving, of course, IV bicarb for the acidosis, give fluid, and so forth. So here we go. Every time you move protons, you move bicarb at the same time, and they always go together, protons and bicarb. So now you have your answer, at least for why aspirin was a mixed type of setting. Well, let's take a little break. Keep on asking me some questions, then I'll do it in numbers for you. And then if you want, we'll look at tubular function